it just depends on how quickly I'll pick it up.
Okay.
If you pick it up, then no, not really. But if not, then I have a bunch of examples I can do.
Okay.
All right, so the first ones are find f of g of 3 and also g of f of -2. So there's a couple ways you can do these problems. You can either like plug like g into f or f into g and then plug in the number at the end. But you can also plug in the number to like whatever function is like the second one first and then just plug that number in, which is the easier way to do it, and it doesn't matter which way you do it. So I'm going to probably do that way because it's easier. So 12, we have f of x is equal to x squared minus 1, and g of x is equal to 2x minus 3. So for f of g of 3, I would go ahead and personally plug in 3 for g of x and then plug that number into f of x. So I usually do this. I usually use this notation anyways because I don't really, this one is can be a little more confusing about what's happening. So this one's going to be f of, or well, I usually do these in pieces. So anyways, let's just do this g of 3 first. So 2 times 3 minus 3, and so that's 6 minus 3, which is 3. And then f of 3, so then it would be 3 squared minus 1, which is 8. Are y'all tracking with that? Okay. Let's do the other one. So then g of f of -2. So I would do typically like this. So f of -2. So anywhere we see an x in f of x, we're going to put a -2. So -2, and make sure you put it in parentheses so that you actually get that the negative is being squared also, minus 1. So that's 4 minus 1, so that's going to be 3. And then g of 3 is going to be 2 times 3 minus 3, which we've already done that technically, and that's equal to 3. So the other thing we could have done just to show you is we could have done it and put the number in at the end. So if I did that, I'm just going to show you for the first one. So f of g of 3, so what I could have done is anywhere I see an x in f of x, I would have put the function for g of x. So, let me do it this way. And I would just plug in 3 at the very end once I'd multiplied everything through, but it takes a lot more lines of work that you don't really need. So I would have 2x minus 3 squared minus 1. And so then you would have to multiply this out, combine like terms, simplify it down, then plug in the number, which is fine, but it takes longer and is a lot more work than just plugging in the number to begin with, when that's really all we need to do. So it went from 6 lines down to 3 by doing it the way we did it, basically.
So do you just always, for like the f of g of 3, does it just always go to the g, and the g of f -2 go to the f of x? And it's just kind of opposite.
So that's just what they're asking us to do.
Oh.
If they could have given us any number to plug in, and we would just be plugging in that number.
Yeah.
Yeah. But yes, that is. And it's always the second thing that's listed is what the number is officially getting plugged into if you do it first.
Okay.
Like, don't plug 3 into F and then try to plug G into F, because then there's nowhere to plug the number. Because, like, that would be doing it backwards. So it always goes into whatever's written second. That's why I like this notation better, because it clearly states where it's going. So, and I think on quizzes and tests, I normally write it this way, but I might, because of the way that they write it in the book, I may keep it the same way. I don't remember off the top of my head. because we do these in different classes, I think some classes I have it written one way and others I have it written another way. So let's do another one like this. So the same thing of the f of g of 3 and the g of f of negative 2, but they give us a different f of x and g of x. So 14, f of x is equal to x over x plus 1. G of x is 9 minus x squared. So I'm going to do f of g of 3 first. So g of 3, anywhere I see an x in g of x, I'm going to put a 3. So 9 minus 3 squared. So that's going to be 9 minus 9, which is 0. So then back in f of x, I'm putting 0. So then I have f of 0, which is 0 over 1, which is just 0. And then g of f of, what was it, negative 2. So I'm going to do the f of negative 2. So that's going to be negative 2 over negative 2 plus 1. So that's negative 2 over negative 1, which is going to be positive 2. And then g of 2, plug in 2 for that, is going to be 9 minus 2 squared, which is 5. So if they give you something to plug in, I would say always plug it in first, makes your life easier. The next problems want f of g of x and g of f of x, nothing to plug in, so we're just going to basically be setting it up. If we can reduce things down, we will, but in a lot of cases, there's not a whole lot that can be reduced by just the nature of what they gave us. So, these ones are looking for f of g of x and g of f of x. So 16, we have f of x is equal to x squared minus 1, and g of x is equal to 1 over x minus 1. So f of g of x, so anywhere we see an x in f of x, we put the entire function g of x. So this is going to be 1 over x minus 1, the whole thing squared, minus 1. And so you can either leave it here. The only other thing we could do is, because this is being squared, is we can put the square here and the square on this part down here and get instead, and I'm trying to see which way they leave it. The answers aren't in the front, so I don't know, so we're just going to guess. So the only other way I could write it is I could have basically 1 over, let's see, x minus 1 squared would be x squared minus 2x minus 1 plus 1. Yeah, plus 1. Minus 1 out here. So basically, you can write it either way. I don't really care. I'm more so just telling you that for the purpose of checking your answers, that they may do it this way, they may leave it. I'm not really sure, but that's what's happening. All right, and then for g of f of x, basically same thing, just reversed. So anywhere I see an x in g of x, I'm putting the entire function of f of x. So this is going to be 1 over x squared minus 1, and then minus 1 from here. So then combine just to simplify it. So this is going to be 1 over x squared minus 2. And then that would be how you would leave that one.
For the second option of how to write it, where did the negative 2x?
The middle term when I factored x minus 1 times x minus 1.
Oh, okay.
Yeah, I just did. And then that's what gave me that there. And if you like wrote it this way and then let's say you factored it wrong, but you had at least this part right, I'm probably not really going to take off points because you at least have one of the methods. It's really, like I said, more just so that in the event that you're checking your answers and you're like, my answer doesn't look like this, you would know, oh, here's something else I could try and see if I get the same answer. Let's see, 20. F of x is equal to x cubed. G of x is equal to the cube root of 1 minus x cubed. So f of g of x. So I'm going to be putting the entire function g of x in here. So I'm going to put this in parentheses just because it's a like big thing that it's happening to. So this is the cube root of 1 minus x cubed, and then that whole thing is being cubed. So if I cube a cube root, what happens?
It cancels, I guess.
Yeah, it cancels. So with this one, we would just be left with 1 minus x cubed. And so, like, to get this one fully correct, you would need to show that you basically canceled it out. So you would need to show, like, you know, basically that you set it up and then that you got to here. So now, not a ton of points if you didn't cancel it, you know, 10 points off, but still, you need to make sure you show that. And then the other one, g of f of x. So this one is the cube root of 1 minus, then this is where I would put this in parentheses, x cubed, because that's what's getting plugged in for x, and then the whole thing is cubed. So then to simplify this one, I would have the cube root of 1 minus, so this would be x cubed cubed, so we multiply, so that would be x to the 9th. And then that's where you would leave that one.
Could we not simplify that to 1 minus x cubed?
How?
I'm not exactly sure.
No, you can't, because this is in here together. Now, you could possibly say this is a difference of cubes and reduce it inside and write it as like 1 minus x cubed. And then like in parentheses, you know, whatever. But you don't need to do that because it's not going to reduce any farther. But no, you cannot take it any farther than that to take anything out of it, which would be the only option. All right, let's look at one that's a little bit harder that actually requires a little bit of work. These ones have been pretty nice so far, but this one, not so much. F of x is equal to 1 over x plus 1. G of x is equal to 1 over x minus 1. And I'm sure now you see why I said not going to be quite so nice. Because I can't just leave a fraction in a fraction, so I'm going to have to do some work. So f of g of x. So anywhere I see an x and f of x, I'm putting g of x. So this is going to be 1 over x minus 1 plus 1. So any suggestions on what I might need to do here? can't have a fraction and a fraction, so thoughts on what I might need to do to get rid of the fraction and a fraction?
Multiply by the reciprocal.
Okay, I can't do that yet. There's something I need to do before that, but yes, ultimately that is what I'm going to do.
You can't cancel out the ones, right? And you factor out something.
I think you're on the right track, but you're not saying the right word. So describe to me what you're saying.
Like, take out something, and then you'll have, like, I don't know.
I mean, you could take out a 1, but then you'd just be left with all the other ones.
You'd still have the same thing.
Yeah. Take out as many ones as you like, though.
So if I wanted to do, what would I need to do to do that?
Common denominator.
Okay, so now what might I need to do over here?
Find a common denominator.
There we go. So I'm going to replace this 1 basically with x minus 1 over x minus 1. Okay, now because that's a 1, that's the only reason I can replace it. Otherwise, I'd be multiplying. So now I have a common denominator, so I can rewrite this as 1 over, and this is going to be 1 plus x minus 1 on top, on top of the bottom, over x minus 1. Make that line a little longer. So on the top of the bottom, the 1s are going to cancel. So I'm left with x over x minus 1. So now I can multiply by the reciprocal, which because there's a 1 on top, that just means in this case it's just going to flip. So this is going to end up being 1 times x minus 1 over x, which I can just write as x minus 1 over x. So then the other way, g of f of x so it's going to be 1 over x plus 1 minus 1. Suggestions?
C.
So this one's going to get multiplied by, I'm going to say it that way instead of replace because I don't want you to get confused if you have one that's not a 1. Now, the thing to note about this one, though, is to watch this sign here just because it's going to be minus x minus 1 when we do the top of the bottom. Okay, so I've got 1 over 1 minus x minus 1 over x plus 1. So again, the 1s are canceling, so the plus 1 minus 1. Now multiply by the reciprocal, which because, again, since it's a 1 on top, I'm basically just rewriting it. X plus 1 over negative x. And the book may put the negative out front, that's fine. They just whatever you do, don't stick it on top because that technically is going to make it wrong unless you do minus x minus 1 on top and then a positive x on the bottom. So. All right, so then the next thing we have is the reverse of this. So they're going to give us one giant function, and basically we're going to decompose it. So we're going to write it as 2 separate functions. So 24. Y equals, in parentheses, x cubed plus 1 squared. And the other thing I'm going to say is there could be multiple ways to decompose it. Okay, so you all three could have something different than what I have, but it still works. So if for some reason, and I say this every year when I do this, if for some reason on a quiz or a test I mark it wrong and you're like, but I think this really works, just show it to me, because sometimes I don't register, like as I'm going through and grading, I don't register, oh, that was a decomposition problem, and so their answer could have been different. I try to make a note of it on my paper when I like make the key that, hey, answers may vary or something. But there's different ways that you can do most of these, so don't be surprised if you don't all get the same answer for your homework. And the back of the book probably will give an option for the answer, but again, it may say something like answers will vary or something like that. So, all right, so basically it wants us to do this is f of g of x is y, okay? So g of x is going to be the inner function, f of x is going to be the outer function, basically. So we're going to have an f of x, and we're going to have a g of x. So I would always do your inner function first, and then go to the outer one. So the one that would come to my mind is that the inner function being anything that's in parentheses, and then having anything in the outside the parentheses basically being my outer function, f of x. So that would make my inner function g of x, x cubed plus 1. And then my outer function, this one, it just requires you to make sure you pay attention, because now my outer function would be x squared. So if I plug it back in, so if I plug in g of x to f of x, I would have in parentheses x cubed plus 1 squared. Okay. Another option for this one, you could have had, you could have said that g of x was x cubed. And we could have said then that f of x was, in parentheses, x plus 1 squared. And that's going to give me out the exact same thing, but it's two different ways that you can write it. So that's why I want you to realize that, you could write them multiple ways. Always just plug it back in, even if it's just mentally plug it back in and make sure it, does give you what you think it does, so that you don't risk getting, in theory, these should be some easy give me points. But it often happens that somebody doesn't pay attention and they, don't write the plus 1 or something like that, and then it ends up being wrong. So, 26. Y equals 1 over x cubed minus 5x plus 3. All right, so any ideas for my inner function? I say my inner function, my function that's getting plugged in. What looks big and scary about this function?
Minus 5x plus 3.
Yep, so the whole denominator can be my g of x. So what would that make my f of x?
1 over x.
Yep, 1 over x.
So pretty much whatever we took out and put as the g of x, we'll fill that in with just x.
Basically, yes. And so if I plug it back in, I get the same thing that I started with, so I'm good. So a lot of times we say anything in parentheses, anything in a denominator, things in an exponent. Those are kind of the things that I'm looking for to say, this is my inner function. So another example, y equals e raised to the sine of x. So my quote-unquote inner function would be what?
Sine of x.
Sine of x. And then f of x would be,
E to the x.
yep, e to the x. Yeah. Do y'all need to see another one of that, or you feel like you're okay with that? Okay. The other thing with this one up here, just so you have another one where you could see another option, we could have instead said that g of x was just x cubed minus 5x. And then I could have said that f of x was x plus 3. Okay. So that's where I just want you to see, like, again, there's another option that you could have. Now, I always go for the simplest option, which would have been this one. But if you're like, well, that's not what I thought of, totally fine. All right, the last thing says to find two functions defined implicitly by the given relation. So 38. X plus y squared equals 25. So basically, all this means is get y by itself. Okay. So subtract x. So y squared is equal to 25 minus x. Then I would take the square root. Now remember, taking the square root gives me 2 answers, so I would have plus or minus the square root of 25 minus x.
Can you simplify that down to
What did you have in I term if you did that?
the square root of 5? Oh, no, because of that. Never mind.
Yeah. If it wasn't being added and subtracted, if it was like 25x, yeah, I could, but since
Okay.
it's being subtracted, I can't. And obviously going back to the section that we were just doing, or 1.2 and 1.3, like, if I have anything bigger than 5 plugged in here, I'm going to have a problem with my domain because it's going to give me a negative number inside. So obviously, as far as domain, like, we don't care about that with these, but I would have to be careful what's in here because of the minus x, obviously. More so just a reminder because, why not review for the quiz that's on Thursday? 40, 3x squared minus y squared equals 25. So basically, same thing. Subtract the 3x squared, so negative y squared equals 25 minus 3x squared. When I divide by the negative, I'm just going to flip the number so that I have the positive in front. So y squared is equal to 3x squared minus 25. And then square root y equals plus or minus the square root of 3x squared minus 25. So as long as you can get y by itself, you're pretty much fine with this section. I mean, with this chunk of problems. So that appears to be the last thing we need to really look at in this section. So any questions? Anything? So I'm gonna give you some problems from what we've done. I'm going to try not to give you like a ridiculous amount of them. If you feel like you need to do more, obviously do that. But let's see, 11, 17, 21, 25, 29, and 29 is one that there's definitely several ways you could do that decomposition. Like, I'm looking at it and I can see at least 2, if not 3 ways that I can immediately see that you could do it. So don't be surprised by that. 37 and 43. Now, the other thing I will say is if you ended up with just like the square root of like, 9 or something like that, obviously there's going to be x's in there, but if you end up with something like that, obviously you know how to take the square root, go ahead and do that for these problems. But there's just nothing we could do with those, which is why we left them. So,
Could you go back up to the first example you were on Friday?
yeah. Does everybody have these numbers written down? Basically, these were just adding and subtracting and multiplying and then dividing the functions. Basically all we did with those. But yeah, I can